So this function is on graphing polar functions, and this time the functions will produce graphs that are referred to as roses or flowers. So here's a parent function for the sine graph. I got those by thinking about graphs, these points around the unit circle. At 0, when theta is 0, the y-coordinate is 0. At pi over 2, the y-coordinate is 1. At pi, the y-coordinate is 0. 3 pi over 2, the y-coordinate is negative 1. And at 2 pi, the y-coordinate is 0. Now remember that we need to undo what's being done to the theta in here, so that I get 1/2 of theta. And then this will be 6 times the r values from this table here. So half of these will be 0, pi over 4, pi over 2, 3 pi over 4, and half of 2 pi is pi. And then if we multiply these by 6, you get 0, 6, 0, negative 6, 0. And if we graph those, 1, 2, 3, 4, 5, 6, it starts at 0, and then at pi over 4 we're up to 6, pi over 2 back to 0, down 1, 2, 3, 4, 5, 6, just off the edge here. And then we're going to go all the way to 2 pi, because when we graph the polar function, we don't stop at 0 to pi, we've got to go 0 to 2 pi. So even though that ends up being 2 cycles of this graph, that's fine. So we get this curve here. So let's go ahead and plot the points that we have. We definitely have a point at 0, 0. And pi over 4, 1, 2, see, pi over 4 is here. It's kind of nice to emphasize where the vertical and horizontal lines are. And you know, pi over 4 is right in the middle and out to 6, and there are 6 circles here, so we have that. And then 3 pi over 4 negative 6 is actually 1, 2, 3, 4, 5, 6 going to be here, because this is 3 pi over 4, but negative 6 will go this way. Now that's all that we get from the table, and that's why it's kind of nice to have the graph here. So we go back to pi, we're back to 0. Then here at just past pi, a quarter of the way past pi is 5 pi over 4. That's out here. 1, 2, 3, 4, 5, 6. And then here when we get to 7 pi over 4, it's a negative 6, so that comes to right here. And that probably will be enough for you to draw the curve in the future on your own, just having those points, but I think the first time understanding where these different bits of curve come from is kind of interesting. So first let's grab a new color here, and this part here starts at 0, goes out to pi over 4, and back to 0 again by the time you get to pi over 2. So right here, as I start off, I'm right at 0, and then I go out to pi over 4, out to 6, and then back to 0 again. And then this part here, when the angle is headed toward pi over 2, I'm actually going negative. So in this region here, I'm going to be headed toward, it was this point, right? 3 pi over 4. So I'm going to head toward so when I'm at 3, in between pi over 2 and 3 pi over 2, this region here, that's this part right here between pi over 2 and 3 pi over 4, I'm going to be graphing the negative parts of that curve. So this portion here actually comes in here. And then this part, going back in this region here, it's still negative. So I'm going to be here, headed back to 0 again. And then here, between pi and 3 pi over 2, I've got a positive pedal. So this is pi to 3 pi over 2 gives me this pedal. And then between 3 pi over 2 and 2 pi gives me this pedal. So again, fairly sloppy. That's this part. But hopefully that gives you an idea of how we got that. Now, if you had just had these 4 points plotted, you would get this anyway, and it doesn't really matter whether you know that the curve traces out in this order. We're going to graph it on the graphing calculator in a minute, and if you watch carefully, you'll see it come around here first, and then here, and then here, and then here. That made it look a lot worse. But that order, I think, is kind of fun to think about how it will end up playing out. So let's see what that looks like. If we change the graphing calculator to the function 6 sine 2 theta. Now, window-wise, we need to make sure we can see out to at least 6. So our y scale needs to be a little higher. And I'm going to bump this up to maybe 9 so that it stays proportional. And I'm going to use a little trick I know. I want it to go a little slower than it might otherwise, so I'm going to make this maybe 0.05. And you can leave it whatever it was before. This just says how often it's going to stop and plot a point on the graph. And by having it be a small number, it will slow the graph down a bit. Alright, here we go. So there's 1 pedal, 2 pedal, 3 pedal, and the last one up here. So pretty. Alright, so you could see how that might look different if you had changed it to a cosine function instead of a sine function. So still 4 pedals, but now it's rotated a little bit. You could see what that looks like if instead of 4 pedals, instead of a 2 here, which gives you 4 pedals, if you put a 4 here, see how many pedals you get. You get 8 pedals if you have a 4 there. And keep playing around with it. We're going to do one by hand in a minute with a 3 there, so I'm not going to show you that right now, but you could even try 8 pedals and see, or 8 for the value there, and see that I'm pretty sure you'll get 16 pedals. So the graphs are beautiful and fun, and I'm sorry I missed this lesson with you today because I think it's kind of cool. Alright, let's do the next one. Okay, so here's the parent table for cosine, just finishing up at 2 pi, the cosine is back at 1. So this function, we're going to do 1/3 of all of the theta values. We're going to do 1/3 of the theta values and 5 times the radius values. So this is 0. 1/3 of pi over 2 is pi over 6. 1/3 of 0 is, oh, this should be pi here, sorry. 1/3 of pi is pi over 3. 1/3 of 3 pi over 2 is pi over 2, and 1/3 of 2 pi is 2 pi over 3. So this is scaled nicely for this situation, and let's do these real fast. 5, 0, -5, 0, 5. So over 0 and up, 1, 2, 3, 4, 5. over pi over 6 and up 0, over pi over 3 and down 1, 2, 3, 4, 5, over pi over 2, which will be right here, up 0, and 2 pi over 3, 1, 2, 3, 4, 5. Alright, and then we're going to fill in the rest of this with the same pattern. It's just going horizontally 1 square and then up and down between 0 and 5 and negative 5. So just following the same pattern. And remember, that's because when we graph a polar function, we need to see what happens all the way between 0 and 2 pi. We can't just stop at one cycle of this graph. We have to send the theta values to 2 pi. Okay, so each one of these kind of represents a petal on the graph, just like these represented one. But something funny happens with when the b value here is an odd number. So let's see what happens when we graph them. Over 0 and out 1, 2, 3, 4, 5. And back to 0. At pi over 3, we're going to negative 5. Then back to 0. And at 2 pi over 3, we're going out to positive 5. 1, 2, 3, 4, 5. And then back to 0. And at pi, we're going to go to negative 5, which is actually going to land right back on this point again. And at 4 pi over 3, we go to positive 5, which is already there. And at 5 pi over 3, which is down here, we go to negative 5, which is also already there. So the graph just wraps around on itself twice. So this first part here starts out at 5 and comes back to 0. This part right here is this right here. And then this here is the one that was at pi over 3 but went negative. And then back to 0. And then this part here starts from 0 and goes to the 2 pi over 3 petal. And then this part here is headed toward pi but is negative, and so it completes this petal. And then the rest of this just does all of this again. So this part is part of the green petal, and this part between headed out to 4 pi over 3 would be the red petal again. And then this part here would be the orange petal again. And then this part right here would be the other half of the green petal again. Alright, so let's check that on the graphing calculator, which we're going to change this function to 5 sine 3 theta and graph it. And notice here it's still working right now, and what it's doing is it's going right back over itself even after it finished the whole thing. So you get a 3-petal graph when there's a 3 here, but you get a 4-petal graph when there's a 2 here. So it's an even-odd situation, and you could explore what happens if you put in a number that's not an integer. So try 2.5 or something like that. Okay, good luck.